This is a video summary of Chapter 11, Section 1 for Science 9 for Mrs. James's class, and this section of the chapter is covered in our first checkpoint for the chapter, and it's covering Newton's first and second law of motion. And here's the learning targets right here that are covered in this section. Notice that they're going to have to write both laws of motion and give examples of both, in addition to learning target 5, having to solve some problems. The versions of Newton laws that they learned while they were in junior high were simplified based on new ideas that the students are learning this year. We have a more correct version of laws for them to memorize and give back to us. So when we ask the students to, for instance, write Newton's first law of motion, we mean with the more grown up, I guess you could say, version that they've learned this year, not the version they learned last year. Newton's first law of motion, most of the students learned it one of these two ways. Neither of these ways are correct. This is the most popular way that students know, maybe the version that some parents recognize also. The problem here is with this word outside force. Objects can receive an outside force and not change their motion. If that outside force is balanced, the object is going to continue doing what it used to do. It has to be an unbalanced force. If students have a hard time remembering the difference between a balanced and an unbalanced force, they should go back and relook at Chapter 10. So Newton's first real law starts out with these words. An object at rest will stay at rest, and an object in motion will stay in motion, which is an awful lot of words that can be replaced with here in red. An object will continue in its state of motion. Please notice that it doesn't say an object will continue in motion. State of motion is important words here, because that state of motion might be at rest. Also, outside force, we don't want to go that. We want to replace it with a more correct unbalanced force. So you put that all together, and you get an object will continue in its state of motion until acted on by an unbalanced force. We then watched some video clips of this happening. There were some video clips from some crash tests where you saw the crash test dummies continuing to move forward at 35 miles per hour until they encountered an unbalanced force that may have come from the seatbelt or the dashboard or the airbag in front of it. We also looked at a video clip of a ski jumper who was continuing to fly forward and up until they encountered the unbalanced force of gravity, which brought them down again to the ground. Or also just a soccer ball. It's at rest. Until someone kicks it and applies that unbalanced force to it, it's going to stay at rest. Newton's second law of motion is F equals ma. We have a triangle for this, which I'll show you just in a minute. And one of the questions they had for the students was, why in this picture do I have the F as blue and the M and the A in red? These situations where you see Newton's second law of motion always involve two objects. The force is coming from one object, the mass and the acceleration referring to the other object. So if we know the mass of a soccer ball and we know its acceleration when it gets kicked, we can calculate how strong the force was that kicked the ball. Here's that new triangle. The F is up here, the M and A are down here. Like before, if you know the F and the M, you divide. If you know the F and the A, you divide. If you know the M and the A, you multiply. Mass is measured in kilograms. Acceleration is measured in meters per second squared. Force is measured in kilogram meters per second squared, which is quite a mouthful, so that's abbreviated in newtons, which is a capital N. Now the math problem is just what we've done before. You're plugging in, what do we know in this problem? We know the mass, we know the acceleration, we're trying to find the force. Students would write the triangle, they'd fill it in, and they answer it with units. We are solving for force, so our answer would be with the units of newtons. We practiced this quite a bit with a variety of problems. They also had a worksheet on that they did for me. We reviewed the laws again. How do you write this? So on the test, when I say write Newton's first law of motion, an object will continue or stay in its state of motion until acted on by an unbalanced force. If they prefer, they can say an object at rest will stay at rest, and an object in motion will stay in motion until acted on by an unbalanced force. And Newton's second law of motion, F equals ma. Students are also going to have to come up with examples of this. For Newton's first law of motion, I want to see a discussion of the original motion, the force that changed it, and the new motion. What students are going to be tempted to do is to tell me the position of object, which is not what I want. I want their motion. So here's a good example. The soccer ball is at rest. Somebody pushes it with their foot or kicks it with their foot, and now it's flying through the air. You notice what I didn't say? I didn't say that the soccer ball is in the grass and it gets kicked, and now it's in the air. That would be position. I don't want position, I want motion. At rest, gets kicked, flying through the air. Or the original motion might already be in motion. The baseball is flying through the air, the force of gravity pulls it down, and now it's at rest in the grass. F equals ma. This is a little bit harder to come up with examples with. The easiest way to do this is for the student to make up a math problem. Let's have something get accelerated or decelerated. You could tell me its mass, you could tell me the acceleration, and then ask me to calculate the force that caused that change in motion. For instance, an acorn is falling from a tree. You could tell me the mass of the acorn. Its acceleration is 9.8 meters per second squared, and you could ask me to solve for the force of gravity pulling down the acorn. Or you could give me the force and the acceleration and ask me to solve for the mass. Not the only way to give an example. Anytime a student, though, tries to give me an example of Newton's second law of motion, they should make sure that their answer contains the word force, mass, and acceleration. If they're not using those three words, they're not doing it right. This is just 4 examples of situations that they might have to come up with. So I might say, give me an example of Newton's first law of motion that could happen in a car accident. Or give me an example of Newton's second law of motion that might happen in a football game. Or at the circus, or at the zoo, or the playground, or the hallway, or in the kitchen. So they should be able to give me a good example of Newton's first or second law of motion in any situation I can come up with. Now, a lot of things, if they work in one situation, would work in another. For instance, if you're talking about a car that's sitting at a stoplight and another car hits it from behind, that same kind of physics would apply to a football that's on the ground at a football game and it gets hit by a football player's foot. It's the same kind of physics. A playground, if you're talking about somebody pulling back a swing, it's the same kind of physics as somebody opening a locker in the hallway. So students come up with a good few ideas that they can use as examples of Newton's first and second law. It then should be pretty straightforward for them to be able to apply those in any situation I give them.